Welcome everyone to our weekly Kubernetes Master Class. This week we're talking about, do I have the right one? Well, today we're talking about K3S streamlined deployment of global edge applications. Sorry about that. I had two different PowerPoints up. Make sure I look at the right one. So I'm Jason Van Brackle. I'm the Director of Community with Rancher Labs. I'm either Jason Van Brackle or JVB everywhere, so feel free to reach out to me anytime. Also with me today is Joseph Marhi. He's an ecosystem engineer with Packet Labs. Joseph, are you here?
Yep. Hi. Thank you for having me.
Awesome. Thanks for being here. So as always, we're going to try to keep this somewhere to 40 to 45 minutes, but it's not unusual for us to go, an hour or more with questions. Questions are welcome. I'll be monitoring the questions tab here on the GoToMeeting. I'll also be monitoring the Master Class channel on Slack. So we'll try to respond to everything. If we can't, I'll push you over to Slack, and you can come talk to me. I'm again at JVB. And then if your question is private, mark it as such so I don't reply to all. And again, this session is being recorded. So if you have to step away, eat breakfast, eat lunch, eat dinner, anybody listening right now will get this recording or a link to this recording later on down the line. And join the conversation on Slack. As I mentioned, if you'd like to follow along with the Masterclass channel, you can join our workspace at slack.rancher.io, put in your email address, you'll get an invite to the space. There are about 11,000 users out there, and I believe about 200 to 300 online right now. So you can join us in the Masterclass channel or talk to me directly at JVB. With that, I'm going to pass the baton over to Joseph and let him get started. And again, I'll be answering questions here on the GoToWebinar and on the Slack channel. And anything that I can't answer myself, I will pass on to Joseph. So Joseph, remember to ask every once in a while if we have any questions.
Awesome.
Cool. And with that, Joseph, the floor is yours.
So hey, y'all. I'm going to talk a little bit about my experience, my work with Packet Labs, with edge compute, particularly with Kubernetes, containerized workloads, and in particular the wonderful K3s from Rancher. And it's been a huge, it's been of immense value to our clients and our customers pursuing an edge strategy. So I'm very excited to get to share some of this with you today. I'm just going to give you a little bit of background on what we do at Packet Labs. We're a team inside of Packet Host. Some of you may be familiar with us. We are a bare metal cloud. Everything runs physical hardware, physical networks. We have all of the flexibility of your common public cloud providers, but it comes up on real hardware, quick and efficiently. And at Packet Labs, what we do internally is, here's our mission statement. We craft solutions to uncommon problems that live at the intersection of hardware, software, and networks. In my case, that means bringing my experience with Kubernetes to customers trying to pursue a container-based strategy, no matter what that is. A little bit about me personally. I call myself customer-first solutions obsessive. I'm always focused on what the user experience is going to be. It's great to have SLAs, SLOs, all these different metrics you can meet, but if your customers are not feeling satisfied, that may not mean a whole lot. And that's definitely my hope in advancing some of these technologies, advancing these patterns, and just creating the best architectures we can. I've worked in the infrastructure space for a very long time. About 11 years now, and a lot of that has been with Kubernetes, and so it's something I spend a lot of time thinking about, thinking about what can break, what works, what doesn't, what's robust, what isn't, and it's been a real journey. If you're not already in the Packet community Slack, I'm there at joseph.packet, and my email is just joseph@packet, and just a quick introduction of the rest of our team. We have a very active GitHub presence where a lot of our projects, our OpenVMC work, our other Kubernetes work, a lot of that is in our Packet Host repo on GitHub. So I'm going to go ahead and just get into the meat of the material here. And we're just going to talk a little bit about what the infrastructure edge is, how that differs from the mobile edge, which is probably the more familiar pattern to a lot of users who may not work in the infrastructure space, but either consume or provide edge services. We're going to talk about some of the edge architectures that I've seen in the wild. And then we're going to talk about some of the applications that are powered by these tools, and then the emerging use cases that I'm seeing. A little bit about orchestration, about how an upward trend between the number of devices running this software versus the lower profile of the hardware running this software gets standardized, managed, rolled out, etc. And then we're going to talk a little bit about just containers on bare metal in general, and what we're doing at Packet to kind of mesh all this together. And then I'll demonstrate one of these patterns with a project I've been working on for some time at Packet for this software. So I give this internal talk every once in a while about what Kubernetes is, how Kubernetes works, and if you're here, chances are you're familiar with how a traditional Kubernetes cluster operates. But I like to reduce it down to these points. I like to talk about the behavior rather than the technical stack, just because this can change, but the architecture will remain the same. You schedule resources, and then it reconciles changes in that state. If you say, I need 3 replicas of this, it needs to abide by these scheduling affinity rules. That's the job of Kubernetes, to reconcile that. And this is probably a pattern you're familiar with. If you're here, you operate Kubernetes with any kind of regularity. And the architecture changes somewhat for something like this, for K3, but the behavior is largely the same. And particularly where these clusters are self-contained, they may or may not be aware of each other. But in this kind of globalized scenario that we're going to be talking about shortly, it's important to remember these things about Kubernetes, just the behavior that you're trying to mesh together into what I'll describe later as a Kubernetes underlay for this kind of global edge strategy. So let's get into it. Here we go. So what's the infrastructure edge? So the infrastructure edge is, well, let's back up a second. So your mobile edge is anything in your home, an Internet of Things device, a smart thermostat, a cell phone, a sensor on a rental bike or something. Anything anything that's going to be interfacing up with a centralized service, but it's going to do some of the intelligence there on the device. So in the case of a bicycle, for example, it might compute, geographic data or weather data where the vehicle is, and report that back up to a data center. The infrastructure edge is the opposite side of that, where you might rather than having two big core sites, one on the East Coast, one on the West Coast, you might have smaller points of presence all over the place. So a biker in Chicago would be connecting to a point of presence in Chicago. And that might be a tiny edge site where just a tiny fraction of the work goes on, but it's basically a chain of events where on your mobile edge device, some of the work might get done, a lot more of the work might get done on your infrastructure edge site, and then stuff like persistent storage or the real heavy lifting of data processing might happen in your core site. And a core site could be anything. It might just be your on-prem data center, or your big deployment on AWS, whatever that might be. Your edge sites might be a little leaner. It might be just a handful of devices. It could be as simple as a couple of NUCs. If you're familiar with that excellent blog post about using Kubernetes at Chick-fil-A, that's an example of this kind of pattern where local devices will do some processing locally and then ship upwards or ship out to other edge sites to kind of create this mesh behavior. And we'll talk a lot more about these patterns as we move on. Do we have any questions so far, or we're good?
We're good. You may continue.
Cool, perfect. Just wanted to make sure we're all on the same page. I want to talk about a common pattern that I've worked with Kubernetes, and more increasingly with this leaner profile Kubernetes implementation, we have in this diagram, you're seeing 3 clusters. There's 2 clusters running in edge operations, and then 1 cluster running in a central location. And these clusters in this diagram are aware of each other. We're using common protocols, WireGuard, for example. There's native implementations of this now for Kubernetes, but this was originally created at the host level. So we had these edge sites running in AWS, and we were able to peer the networks to connect it up to our data center network in a central cluster running the full bare metal workload, persistent storage, all of that. And what was happening at the edge was that so much data was being pushed that the central cluster was getting overwhelmed just with network transit and all that initial upfront ingestion work, that the operations for things like persistent storage and being able to properly deliver data to a cache node or things like that were kind of grinding to a halt, and it was becoming less and less efficient to operate a cluster that way. So what ended up happening was that these edge sites were deployed in a very low profile manner, where most customers were coming from, and a lot of times this was happening on the fly. So, you know, if there was increased traffic in one region, that region would cluster to have more of these edge nodes to handle pre-processing the data, which was significant. There was a lot of data can come from web traffic, and that's exactly what this was doing and processing that data. So part of it was cleaning up that data, doing that initial upfront obligation, and then shipping that data to the central cluster to do the rest of the workload, where there was a little less volume, little less urgency to have it committed. And in this case, in our case, when we talk about something like a database, FaunaDB is the one I mentioned here, just because they do have a very good global replication story. And I think it's a very good use case for this type of architecture, where the edge nodes can be aware of each other, aware of how the data is being stored, how it's accessed, which node to access to get a data that it has a reference to. And the central cluster example is a good one for databases, but also running just a mesh of edge nodes, sorry, can function this way too. You kind of have with a robust enough network, with enough, depending on if it suits your needs, what requirements you might have for performance or uptime guarantees. This is one valid way of implementing some kind of highly distributed data store. This is what I was referring to with the Kubernetes underlays, is the mesh of edge nodes, where maybe you don't have a central cluster at all, and it's just a pool of clusters that are aware of each other. Their workloads at the application layer are aware of each other, and replicating or sharding, more often the case in that pattern. And it's been an unpopular opinion to say that Kubernetes has a good persistent storage story, but I think there's a lot of ways to approach this. And as anyone who has operated storage at this kind of data center scale can tell you, there's a lot of hard work that goes into getting storage right. And if you get storage right, the rest kind of falls into place on top of that. And a pattern like this can be useful if that's the type of global presence your application and the data is required. Before I go on to the next example, is there any questions or?
We are good, Joseph. You may continue.
Perfect. Sorry, I keep going backwards. Another example, and this is my personal favorite example, just because the real strength of edge patterns, edge architecture really comes alive with functions as a service. You can have, in an example where you do have a large centralized presence, maybe you have a big OpenStack deployment somewhere where all your services run, all your VMs, everything, all your data is in one location, but maybe your OpenStack API is slow, or your customers are really far away from your site, so there's not really an efficient way to request data or deliver data or expose data in a way that you would like it to be presented. And a tool I was very lucky to be a part of, seeing developed at Platform 9 was Fission.io. The folks at OpenFast are doing excellent Kubernetes-based function work as well. And what the benefit is of something like this to an edge strategy is that it allows you to rapidly prototype and rapidly spin up HTTP endpoints. And with the Kubernetes ingress toolset, you can do things like equip with TLS, set up any kind of, how aggressively you want to cache, all these things. And it kind of replicates that content delivery network model. And we're going to talk about that a little bit as well later, but in particular, these are the kind of services that you can build very rapidly. And it also allows you to control the presentation of data coming from your central application locations. And the demo we're going to do in a little bit demonstrates this a little bit, but this also allows you to take another globalized approach. Say you have a global load balancer, you have a location-based load balancing. That's pretty common with things like Fastly, Route 53, things like that. Anything that's geographically aware of where the request is coming from. This can be an effective backend for those services, as long as your load balancer can reach the endpoint where you have your fast running. You can deliver that traffic in a very efficient way, the most efficient way possible, and make those users happy with the performance with this relatively low profile, addition to your existing architecture. And like I was saying, a practical use case for this kind of thing is building a content delivery network. And so things like delivering assets, style sheets, images, all that stuff you might have a large Kubernetes-based object storage platform, for example, and that would run in your origin server and your edge servers. Running these functional functions as a service tools can be used to deliver out to the points of presence, and then the points of presence can track cache and time, how long the content is good for, et cetera. However you want to implement this, but it highly enables this model and allows you to deliver to customers a little more locally. And this is just a consumer model use case, but this would apply to hardware developers doing things with smart devices, rental scooters, all the things that you kind of associate with the Internet of Things can operate on top of this model. Before I move on to the next topic, was there anything else? Any questions so far?
Just to go about General Rancher, I'm answering behind the scenes, so go ahead and continue.
Perfect. So I also think the ability to do this efficiently very much relies on the ability to orchestrate effectively. And by orchestration, I mean handling rollout of infrastructure, how stuff gets provisioned, how stuff gets managed, how your environment is being managed. And these concepts are likely new to you, are not likely new to you if you've been working in operations or you've been a developer for some time. Configuration management is a big help here, just to be able to standardize a fleet of servers as it's always been. But when we're talking about the edge, we're talking about some potentially exponential number of devices deployed worldwide that compared to the next tier, which might be your central cluster, or in our example, if we're talking about mobile edge to infrastructure edge, we're talking about billions of nodes, and the orchestration can you need to be shooting to be end to end. It's one of those things. It's like test coverage. If you're at 100%, there's maybe, if you think you're at 100%, you're probably missing something, and it's definitely an iterative process. And the way this has gotten done in our experience, some customers prefer to rely on image builders like Packer to build custom images, Docker images, VM images, whatever hypervisor they're using on top of Packet, for example. To deploy just a ready-made OS image, and that's one way to do things. And particularly important if you're a platform with high compliance requirements, where being able to audit your deployment trail is probably something you want to highly operationalize. And something like Terraform is my favorite approach to this, just because everything's declarative, everything can be targeted one-to-one. So if you do need to get into a more specific targeting mode, you can do that, or you can just wash away the whole environment. And the only real drawback at this scale, though, with something like Terraform is that if your state goes wonky or something falls out of Terraform's awareness, it tends to have this cascade effect. But it's an excellent tool for this kind of work, where scale is really as simple as passing in a variable of how many nodes you want, how many replicas, whatever. And then there are artisanal tools like GitOps, which I talked a bit about the Chick-fil-A model, and this is their tool for managing Kubernetes clusters and rolling them out and managing, tearing down, whatever. And so tools like that are very important to make sure that not just the rollout, but that the nodes all basically look alike when they're edge devices. And being able to scale a pool of clusters is important. And in the demo we're going to be doing, where I'm going to demonstrate this a little bit, just what I mean by cluster pool, which is per facility, how many clusters, how big should the clusters be per facility relative to that of your core site. And as always, your CI/CD tooling for testing Terraform, applying things like Terraform, or applying your configuration management if you're an Ansible user, for example, making sure that that's consistently being state checked is important, and that's something that I consider to be kind of foundational for this kind of edge strategy. If only because you want consistent behavior across this exponentially growing fleet of devices. So even if your mobile edge presence is an app that connects to your edge data center, that's still potentially as many users as there are phones. So that's not an insubstantial number of connections to be considering. So before I move on, was there any questions for me that you hadn't handled, Jason?
You are good to go, Joseph.
Excellent. So, like I said, Packet is a bare metal cloud, and the reason I'm so pumped about an edge strategy on Packet is that we do have this kind of this presence where we can rapidly deploy hardware devices. We don't have to worry about virtualization costs and cost and performance, I should say, and so we can manage the metal directly, and this goes right into production with our native data center networking. And I'll talk more about Packet specifically, but why containers on bare metal, why Kubernetes on bare metal, and particularly for a K3 strategy, having low cost but powerful hardware in these edge data centers allows you to kind of maximize your resource benefits, the hardware platform benefits. Let's say you could deploy an edge device with a GPU, for example, and you want to start doing that GPU workload locally before a bigger cluster with lower power machines, for example, for say their storage nodes or something. You don't need to equip those with GPUs, but your edge devices might be able to do that and then effectively work on the data before shipping it back. So being able to access the hardware, being able to have the hardware platform benefits available to you is a huge performance benefit. And like I say, I was saying here, the virtualization can be an inefficient abstraction, meaning that it's additional overhead if that's the only thing you're using virtualization for, is to provide Kubernetes. If you have access to the metal, there's no reason to introduce this layer, particularly if this is in the service of your application, where performance might be, is going to be one of your top concerns. And that's not to say you can't orchestrate this appropriately, but it adds more things to administrate. And now that's really not as much of an issue with so many hardware providers out there effectively orchestrating for data centers. Things like OpenStack Ironic, for example, are a good example of where this type of automation is coming into play. Container security is another one. Back in 2015, I attended a thing called the Unikernel Summit, and the big discussion was that you had to run containers in VMs in order to secure them, because not even Google could figure that out, and that's no longer true. The community, the folks at CoreOS, for example, Docker, all of the work being done on container runtimes that are Oracle, et cetera, it's come a long way, and being able to secure the machine is effectively that same level of security for running a container on that kind of high performant software. And then you also have the hardware platform security features that you can think about as well. With Edge in particular, that maximization, that ability to target specific types of hardware for whatever your Edge workload might be. The GPU thing is a good example of that, just because you're not equipping every server with that, but your Edge presence might be cost effective or more performant to have it that way. And with Metal, you kind of get to have you have this known quantity for performance. You're not dealing with what they call in the public cloud space a noisy neighbor problem, where maybe your hypervisor is overcommitted or whatever. If you're running your own hypervisors, it's less of an issue, but it's like I said, it's inefficient if you're running it yourself, or can be inefficient. I won't say it's uniformly inefficient. And like I touched on before, this can be handled with the CI/CD patterns are well established. They apply here as well. And now with providers like Packet out there, a lot of our competitors, a lot of public clouds offer provisionable hardware now. And with K3 in particular, you can kind of roll out your configuration as part of this process, as part of the provisioning process. I'm going to move on to more a little bit about what we're doing at Packet to enable this and to enable Kubernetes at large. But before I do that, any questions?
One specifically, and maybe you could talk about this to Kubernetes generally, because the questions are on Rancher, but I think it applies either way. What are the drawbacks of running VMs versus bare metal for Rancher?
I think in general, the largest drawback, and it really just depends on your scale and what kind of workloads are being run, and and there is such a thing as vendor lock-in. So maybe you've been using VMware for a long time or something, and maybe you're not getting the best use out of it, but you're kind of stuck with it, for better or worse. It's an excellent product, but sometimes it's not the right tool for the job. And the big drawback that comes in with virtualization is, and particularly with Kubernetes, because there is a high level of software-defined networking going on. You're talking about running your Kubernetes network overlay on top of another network overlay for your VMs, and they themselves could potentially be on its own overlay inside of the data center. So you're talking about layers and layers and layers of network overlays, and for the kind of velocity and the kind of volume that an edge pattern might best support, that's additional additional time for processing. That's additional time for transit. It can potentially at a certain scale create a network bottleneck where one might not exist if you were running this on bare metal. Kubernetes on bare metal, for example, has a lot of excellent solutions. The Kube router, MidLLB, they all support layer 2 and layer 3 networks, and you kind of don't really lose anything in security as long as you are familiar with, your network engineers are familiar with the requirements of Kubernetes to ACL this properly. Right from your Juniper switches, your Cisco routers, all of that, and less of an issue is just the if you're virtualizing storage, you can still virtualize storage and attach it to VMs. That's a common pattern. iSCSI, for example, stuff like Datera. You can still virtualize storage and you kind of still get that benefit of ease of provisioning. But for the compute layer, that's more virtual disk, it's more virtualization. So you're running a system inside of a virtual disk, inside of a physical disk, and maybe it's single tenant, maybe it's not. There's a lot of moving pieces sometimes that for an edge strategy might not always make sense.
Awesome. Thanks, Joseph. And then Brooks, thank you for the question. The reason I asked that of Joseph for, Rancher versus Kubernetes is that Rancher is in a highly available scenario, which would be in play in this case, it would be running inside a Kubernetes cluster as well. So usually, VMs versus bare metal for Kubernetes is the same question as VMs versus bare metal and Rancher. So Brooks, thank you for the question. Joseph, that's it. Go ahead and continue.
Perfect, and that was an excellent question. So I'm just going to talk a little bit about what we're doing at Packet about enabling Kubernetes. We're big users of Kubernetes. We work very closely with the CNCF. We work with a lot of different projects. A lot of our users are making the jump from public cloud providers and hosted Kubernetes products to running their software on Packet, either directly using the Packet Labs tooling or using our partner platforms. We have a lot of excellent partner platforms that are targeting Packet and making the most use of those physical resources. But particularly what we're doing, we have all of the same developer tools as a public cloud to provision our resources, our hardware, our disks, our networks. And it makes things like auto-scaling a cluster. We're working on an upstream contribution to auto-scale bare metal, much like you would in an EC2 auto-scaling group, for example. And there are third-party tools out there to handle this as well. And without the restriction that bare metal used to have, that you wouldn't be able to treat it like you would a VM fleet, that's not necessarily true anymore. And we get servers online within a few minutes. Everything's up. Networks provisioned almost instantly, and the tooling is all there these days. Terraform provider, Ansible provider, etc. And personally, what I love about our platform is that it's what our co-founders call an unopinionated platform. We're kind of just the raw material. We give you the network, compute, and storage tools to build the things you need to build, where you need to build them, whether that's in a huge core site like Newark or San Jose, or edge sites in Dallas, Chicago, Japan, wherever. And I think that makes it a very effective substrate for Kubernetes in general. In particular, our network automation allows you to remove that kind of virtual network layer and kind of limit it to a single overlay if you want. But our network automation is great for provisioning subnets that get used for load balancer type services. So when you need a deployment to have a service with an exposed IP, either via KubeRouter or MetaLB, for example, you can provision your packet subnet and carve out an IP space for those services. Our layer 2 networking and our forthcoming network features to peer with other cloud providers. It makes a multi-cloud strategy very doable, very performant. And we use an example of this in the demo that I'll show in a moment. But being able to network between the clusters securely is very important. They need to be able to be aware of each other in certain scenarios, or at least aware of the central node. So even if they're not aware of each other, they're aware of their role as an edge cluster. So that kind of connectivity between sites is important. And our third type of networking automation benefit is we offer a global IPv4 address that we call a global IPv4, but it's an anycast address, and it is location aware to some extent. When you make a request to such an IP, for example, it does a best approximation of the quickest backend to respond. Again, which I'll demonstrate in our demo. But these are the types of things that you can build with our somewhat unopinionated raw material provisioner is how I like to phrase this. Before I move on, were there any questions about Packet or any of this work? Or
you are good to go.
Cool, excellent. And Packet and the edge in particular, like I said, we offer multiple core sites, multiple edge locations. We can offer a point of presence in most areas where needed. In the demo we're going to do in a moment, for example, I'm deploying a core site in in Newark and then deploying to edge sites. And when we make the request, you'll see the edge sites service the requests rather than needing to go to the same location over and over again. It'll make some kind of approximation based on where I am, what kind of response times are going on. And our layer 2 and 3 network automation and ECAS IP addressing are diverse hardware. Like I was saying, you can specialize your workloads and tailor them to your deployed hardware in the edge site. So depending on what kind of work you're doing, if you need really high performance networking, you need really high performance storage, you can do that on the edge and then ship it to a more persistent, more cost controlled region where you might have a much larger cluster. Our edge strategy has been that we do have network volume storage in our core sites, so you can build large storage arrays. At the very least, you'll have attached storage options on all host types. This means that you'll have a big menu of hardware options to choose from when you deploy to an edge site. And then, like I said, our community contribution level is high. We want to make sure that Packet is in the conversation, so you can make the most use of this type of architecture, this type of pattern on Packet or otherwise. Just contributions back to these projects are very important to us. We want to be mindful consumers of the technology that we use and contribute back when we can. So I'm going to go ahead and start this demo. And what this is it's a project called Packet K3S, and it is a Terraform wrapper that provisions all the hardware, provisions the networks, bootstraps your cluster controllers in each of the facilities, and then attaches it provisions networks for each of the core sites. So you have a load balancer objects available to you in each facility for your services that are not geographically dependent. So just something that it doesn't matter which it gets routed to. And then we'll attach an anycast IP address for the services that are location aware. So in our example, we're going to deploy an application that just returns the IP address of the node that is responding to the request. So you'll see that when we hit the anycast IP address, it will route to whichever one is the closest approximation of the nearest backend. So let me go ahead and so I created a new project here in Packet. The project ID is the only thing I'll need here. And the only other thing you need to do on Packet is ensure that BGP is enabled. BGP is already enabled here. Normally there will be a notice for you to enable BGP because you'll need this to attach the anycast IP addresses. And Jason, can you see my terminal all right?
I can.
Okay,
just make sure your text is big enough for everyone to read. It's a little small for me. I've got bad eyes.
Let me adjust this up. Okay, a little bit bigger. Let me open my editor for you first. So what we're going to be deploying is going to be based in a module, and the module is your cluster pool. So you're going to create the latest feature in Terraform 0.12 is a for each loop. So basically what each module does is for each facility in a map like this, it'll loop through that and create an instance for each of those values. So in our case, we are setting up facilities in Newark, Narita, and San Jose. And we're just going to go ahead and say that Newark is our primary facility. The primary facility in this example will be the one that gets a node pool attached for storage, et cetera. The rest will just be single instances. What the module is just it bootstraps the clusters for all of these facilities in that pattern. I'll link to this as well at the end of my slide. So if anybody wants to take this for a spin, and I'm going to fire this off in a minute. The module itself, you'll see it creates an IP block for services. So these are just your your service load balancer IP addresses. We're creating a K3S primary in each facility. We're creating a BGP session and then an attachment of our Anycast address to your controller. So each time this spins up, a new backend gets added to that Anycast IP address. And then the last bit is the node pool where things like persistent storage will be going on. The application we'll be deploying, like I said, is just a very a small Go app that just returns to the location of the node that's responding to the request. So rather than your location, it's the location that you're being serviced from. So let me go ahead and Terraform apply auto approve. And while that's running, I'll talk a little bit about more about this application. We have a demo application. We have a couple of roles in here that are just standard Ansible roles. So something to configure RBAC. That's not specific to K3S, but it's important that you be able to standardize this across your fleet. The demo application is an example of rolling out this application I was just describing, and that is K3S specific. So if you want to try this out yourself, I'll be rolling this out in a moment once Terraform completes. Back on the packet side, you'll see our servers are starting to get provisioned. They're starting to grab IP addresses. This will demonstrate how quickly they're spinning up as well. You'll see we're getting a controller in Newark, our one in Japan, our one in San Jose. BGP probably won't be there yet. Yeah. And these are still creating. And you'll see it's provisioning the IP address. It's reserving the IP blocks for each cluster. And just while that's running, this is on our Packet Labs GitHub, Packet K3S, and we have a document about how to deploy all this, how to define a cluster, how to do it manually. We have automated tooling for this inside the project. We go over some of the demo projects, and so if you want to take that for a spin, or if you want to open some issues or contribute, yeah, we are always accepting contributors as well. And okay, here we go. The clusters are bootstrapping. The Anycast IP address is attaching. The BGP sessions are spinning up. And here we go. So we have our Anycast IP address, and that's going to backend. That's going to be backended by the clusters we just created. We'll give it a couple minutes. We'll give it a minute or two to finish spinning up. But back here, we'll start to see our BGP sessions start to populate. Yep, the nodes are starting to show up. The status is still down. They're still bootstrapping. So part of the script that is going on is creating the BGP sessions on the host, configuring the clients, etc. So the only thing I need to do here is update the IP address and save that. And we're using a dummy domain here, packet.dev. So I'm just going to need to update my host file to make sure that I am all good there, packet.dev. Because I'll demonstrate this locally first, and then we'll log into the hosts to do this. In our example directory, we have a script to create an inventory for our demo application. So this script just reads the Terraform state and then creates an Ansible inventory for us to operate on. So it'll be aware of the size of the fleet as Terraform reports it. It'll be aware of those changes, and then that will kind of allow you to continuously apply your Ansible playbooks over it. So the RBAC is a good example of something you might want to make sure is continuously in state, continuously applying. And let's go into. So what we're going to apply here is this demo app role. and we're going to give it our fully qualified domain name, so our dummy domain in this case. But for example, you would point the endpoint you would want users using. So say you have you're servicing your API through a function as a service model. You might have API.business.biz, and you might have 30 K3 clusters in edge sites worldwide. And so you would point that domain name at your Anycast IP address, and the Anycast IP address will route. That's I'm sorry to hammer on that one point, but that's probably my favorite part about this feature. And let's see if our BGP sessions are ready. I just want to make sure before we apply this application and that the clusters are booted. Yep, so our clusters are running. Let's apply. So the inventory that we just generated will have our three cluster controllers in it, and then we're going to apply the role we just configured with our Anycast IP address, and we're going to go ahead and this will also deploy the app. Normally, you might do this with the CI/CD or whatever. It might be its own discrete task from bootstrapping the hosts, but in this case, it's just for the purposes of the demo and this project, it's condensed down into one item. And what this script does is it configures the traffic ingress controller. It configures it to respond on this domain that we passed. So in this case, packet.dev. And then deploys the location app service and creates that ingress. So the location service will be running in each of these clusters, and those will be the data that we're getting back is which node is responding to a request. To save a little bit of time, I've written a small script to demonstrate this a little bit quicker, but since we have plenty of time, I might do this myself. So let's curl http packet.dev. Service is still spinning up, sorry. So this might take another second just because the deployment might still be applying on the back end. We just fired this off, so the pods are still likely creating. Okay, now the pods are running. So let's, and see, there we go. We got our node in Newark. And if we were to do this, on, say, let's do this in Narita. Let me just blow my own host away real quick. A little janky, I know, but so here we go, kubectl, get nodes, and you'll see this instance is running as well. It's been running for about 5 minutes along with the other ones. So let's and you'll see it hit a different IP address. It looks like our geo IP is a little wonky, but it's effectively hitting itself because this node is the closest one to this location. So rather than hitting the node in Dallas or hitting the node in San Francisco, it went to the nearest cluster with an ingress, and in this case, it was itself. And so let's take a look at the script I wrote. Just to we're gonna loop through all of our hosts and see just to demonstrate that it changes, which backend responds to repeated requests to the same domain. So these are going to make requests from different locations to the packet.dev domain, and you'll see that the responding IP is different based on where it's connecting from. The script also just starts by verifying that the IP address is accessible. So in this case, it was. You see this first request from a cluster responded in Newark, another one which I think is San Jose, and then the last one is Narita, and then the last one is my local response again, and it's getting returned from San Jose, which is the nearest to me. I'm in the Midwest, so it's going to be differently opinionated about where I'm connecting from. And that is this sample of servicing these requests. The content. This is an example of that functions as a service pattern I was discussing earlier, where you have these edge sites that can service requests, and if I had wanted, for example, I could be running MongoDB in MongoDB or whatever DB, whatever highly available data store you might have, that might be running in a core site with durable storage, a lot of storage, and maybe you don't want to run a lot of replicas, maybe you don't want to store this data offsite, maybe you don't want shards to get lost, and so what you can do is spin up these fast endpoints in your edge sites to cache data, transform data, return it, receive data, and it kind of just allows you to extend your reach a little bit without having to sacrifice anything in a highly available data situation. And so this is obviously a very basic version of that, but with common network protocols, BGP, it's not a new thing, not always popular either, but it does serve our needs if this was a real company and not just my hypothetical. And we see this kind of thing a lot with users coming from public clouds, coming from hosted Kubernetes services, where that's still an integral part of their deployment, but they need to extend their reach a little bit. They need to be able to say, I need this to be much more powerful, but cost much less, and be a way smaller server, and it allows you to kind of tailor your implementation to your requirements. Like I said, this is on GitHub. So if you wanted to take this for a spin yourself, try out a couple of different edge workloads. That is definitely something that we are receptive to. We're always online on Slack in the Packet community Slack to talk about this stuff. And before I move on, were there any questions, Jason, about any of that?
No questions. Really interesting demo. I'm going to check that source code out. So I'm a big Terraform fan myself. Excellent.
Yeah, I'm a big fan, and I'll add one more thing about this. The way the Terraform project is structured is it's structured as a module. So then you can create your entire fleet of clusters as a cluster pool. So say you need. So this allows you to re-implement the same way very rapidly and target that specific cluster pool. So say you have a higher tier of performance or something in a different cluster pool that does different things, or maybe offers private high performance use for higher paying customers, or what have you. This kind of orchestration, like I was saying, kind of enables you to not just do better operations and not just better reliability, but also it can provide a little bit of grease to speed up business velocity a little bit. Anyway, so if you all enjoyed the demo or liked anything I had to say about this, you don't have to run this on Packet in particular. You can do this on as little as I think the what's the metric? K3S will run on half a gig.
Yeah, it's a pretty tiny footprint. I have K3S and a cool Raspberry Pi sitting here in my lab.
Yeah, perfect. Yeah, see, and that's a lot of the use case we're seeing, these low power devices running this very powerful software tool that we're also using in a much more expanded way in our data centers. And so the possibilities are endless, so to speak here. And if you're interested in the types of things that we're doing with this in core sites and on the edge, the Packet Labs team, we have a full Kubernetes example with BGP support, and that also includes using consuming data center networking, so you're not using overlays at all. Multi-architecture Kubernetes, which is super important if you are ARM users like we are. We are very passionate about ARM, Kubernetes on ARM in particular, and that's why K3S really spoke to us. Plays very well with our ARM v7 and 8 servers. And then the project you just saw is Packet K3S, and all of this is linked in the in this slide. So I assume this will go out as well with the video, but we can share that as well. And I also linked to some of the tools that we discussed today, that if you do want to take this for a spin and decide, maybe an edge strategy is worth looking into, the technologies I talked about, Fission.io, OpenFAS, the Chick-fil-A cluster manager tool, and something like FaunaDB if you're into data, these all help to either enhance or enable an edge strategy. And with this kind of approach, with this highly automatable surface to work with, it gets faster, it gets easier, and Kubernetes is starting to really do a lot of the heavy lifting, and especially if you're a developer. Operations might disagree that it gets easier. It's a thing to administrate, but all of your same tools will work. All of your approaches are valid, and there's a lot that can be done with remarkably little these days, it seems like, and that's one of my favorite things about this project. So anyway, I don't know if I spoke for very long, but I'm open to questions, or if you have any questions about what we're doing at Packet or anything like that.
So Joseph, I got a question from Roger Gomez Olivares. Are the Packet modules in the Terraform main site? So I think you showed a GitHub page. If you could show the GitHub page one more time, and are there also Packet modules available, as part of the standard Terraform, the standard Terraform offerings? Like, do you have a Packet provider for Terraform?
Yep, we have a very well-supported Packet provider. Our community is doing amazing work on this. We do have a Packet provider. It is updated for the latest Terraform, and the Packet K3S will support up to the latest Terraform. I made sure of that myself because I love these new features. I'm loving the new features, and the modules specific to this project will work out of the box with Terraform, and the Packet provider, I should say, as well.
Awesome. Well, that's the last question. Anything else before I take control back of the webinar?
I think that was all I had.
Awesome. Then I will grab the screen. Okay. So thank you for joining us today. Remember, this was recorded. You will get an email with the link to the video, as well as the slide deck with the links that Joseph mentioned. We have upcoming classes. If you want to sign up for that, it's ranger.com/Kubernetes-master.class. If you have follow-up questions, grab the link in the presentation for the Packet Slack workspace. I'm sure Joseph will be happy to answer them there, or the masterclass channel within the Ranger Slack. I'll be out there. I'm pretty much always out there. So with that being said, thank you so much for your time today. Thank you for joining us. Joseph, thank you for the wonderful presentation. I'm certainly going to be checking out some of those links as well.
Awesome. Thank you so much for having me.
All right. We'll see you all at the next masterclass. And that's all for today. Bye now.